All right, in 7.5, we have one more theorem about trapezoids. Hopefully this looks a little familiar to you. The trapezoid midsegment theorem. We had one for triangles, and that's why I had you review in that first video. So if this triangle, the bottom was 8, and we took the midpoints of the other two sides, that length is 4. The same goes for a trapezoid. It works the exact same, but now it doesn't come to a point, so we have to average. We have to average this top length and this bottom length to be able to figure out what that middle length is. So I'm going to just give you an example. I'm going to make one up. So if this top has a length of 6 and the bottom has a length of 12, think about it. Halfway in between those two, what would you predict that middle segment to be? I'm sure most of you said 9. Now the reasoning behind it, the actual algebra behind it, is we add those top and bottom together, 6 plus 12, and we divide by 2 because we're finding the average of two numbers. Well, 6 plus 12 is 18. 18 divided by 2 is 9. Now, could you do that one in your head? Yes, but they're going to get more complex and they're going to involve some algebra. All right, so take a look at this one. You got it. Find that midsegment MN. Okay, so 12 and 28 is 40. 40 divided by 2 would make MN 20 inches. Now this one says find the length of the midsegment YZ. Couple of ways we could do this. One, find the length of TU, which I just so happen to know is 4 square root of 5. And the length of SV, which is 2 square root of 5. Now we can add those two together. 2 square roots of 5 plus 4 square roots of 5 gives me a total of 6 square root of 5. But I want the average, so I divide it by 2. Well, combining like terms here, right? 6 divided by 2 is 3. We still have square root of 5. That is how you would do it using just the ends. But the other way is to find the midpoint of the sides, which they already graphed for you, y and z. And then you can just do the distance formula between those two sides. Guess what? You'll wind up with the same thing, so it does not matter. All right, this next one makes you think about it just a little bit. So I'm going to sketch the picture. And we know that angle J is a right angle, so I'm going to make that angle J, and since M is also a right angle, this is going to be my M, and it goes JKLM. Now, connecting the midpoints, because that's what it says, we got a midsegment in there. We know that JK is 9 centimeters. The midsegment is 12. Can you guess, just logically reason through, what is the length of LM? Did you get 15? Because if you got 15, you're right. So, how do we do that? It's got to be the midpoint or the halfway or the average. So if this is 9, we went down 3 to get 9, right? Up 3 is 15 because we are finding the direct middle of it or that average. The other way to think about it algebraically, we don't know the third side or the third length, excuse me. So I know 9 plus x, my two bases of that trapezoid, divided by 2 has to give me the average, which is 12. Multiply both sides by 2. 9 plus x is equal to 24. Subtract 9 from both sides. We still get 15. So either way you want to think about it, it doesn't matter. It works. All right, let's move on to kites. So for kites, the diagonals will always cross at a 90-degree angle. And you probably knew that, but you just never really thought about it. And I even think about if we were in class, we would make kites, and you've probably seen kites hanging around my room, but those sticks in the kites, they cross at a 90-degree angle. Now in kites, and you can see in this bottom one, only the opposite angles that are between the non-congruent sides, so BC does not equal DC, that's why this angle here in between them is congruent to this one here. It's between the non-two congruent sides. They are congruent, but as you can see, angle B and angle D are not congruent to each other. So it just has one set, and that's why it's not a parallelogram, because it doesn't have two sets of opposite congruent sides. Now I want you to try these. Pause this and try to figure these out on your own. Okay, angle D, what in the world is it? Well, first we know a kite is a quadrilateral, so it has to add up to 360 degrees. So I'm going to take 360 minus 115 minus 73, and I get 172 degrees. That's what I have left to work with. That's what angle D and F are going to be together, 172. Well, what do I know about a kite? The opposite angles in between non-congruent sides are congruent. So D and F have to be the same measure. So I take 172 divided by 2. That makes both angle D and F, whichever one, we're only solving for D, but F would also be 86 degrees. All right, this last one says a kite has these 4 different angle measures. We got to find the value of x. Well, again, it is a quadrilateral. So 3x plus 75 plus 90 plus 120, which is 285. I did a little shortcut. We know those added together have to be equal to 360. Subtract 285 from both sides. 3x is equal to 75. Divide by 3, divide by 3. X is 25. Now it says, what are the measures of the angles that are congruent? Well, to figure that out, we got to plug this 25 back in, substitute it. So 3 times 25 is 75. And now we can see that we've got a 75, a 75, a 90, and 120. So the congruent angles are both 75 degrees. All right, you try these last few examples on your own, and then we'll walk through them together. All right, number 11, the most specific name. All we got is the fact that it's a parallelogram. We know nothing about the side lengths. We know that the diagonals bisect each other, but that's it. We don't know if they're congruent, so that rules out a rectangle right away. We don't know anything about those angles, and we know nothing about the side lengths, so parallelogram is as specific as we're going to get. Number 12, it says a quadrilateral has just at least one pair. Could have more, but at least one. What quadrilaterals meet this condition? Whoa. Well, at least one pair, so 1 or 2. If it had 2, it would be a parallelogram. Could be a rectangle. Could be a square. Could be a rhombus. And it could be an isosceles trapezoid. Because if it just had one pair of congruent opposite sides, right? That's where it could be an isosceles trapezoid or a rectangle. All right, take a look at number 13. What's the most specific name? Well, we don't know anything about the angles, but we can see that we have 2 sets of sides that are congruent, 50 and 51, but they're not across from each other, they're next to each other. Therefore, that shape is a kite. Now the next one is just a plain trapezoid. We have one set of parallel sides. And it's only a plain trapezoid because these diagonals are not congruent. In order to be isosceles, they'd have to be congruent. Now this last one, we do not know that the sides are parallel. Nothing about that. We only literally know that these 2 sides are congruent and this diagonal is bisected. We don't know anything about the other diagonal. We don't know anything else. So, what do we know? All we can conclude is that it's a quadrilateral. We don't have a more specific name for that. All right. Now, this is a wrap on Chapter 7, but I did want to give you one more just to make you algebraically think a little bit more about the trapezoid midsegment theorem. All right, so here we go. This isn't so straightforward. We can't just add the top and bottom together, divide by 2, and oh, there's our algebra. Instead, we actually have to set up an algebraic equation. Well, I still have to take the average. So averaging the top and the bottom, which would be 3x plus 2, plus 11x plus 2. I'm going to go ahead and combine those. 3x and 11x is 14x. 2 plus 2 is 4. Well, I want the average, so dividing by 2 is equal to 8x, that midpoint. This is my average. Now solving that, you could do it 2 ways. You can multiply both sides by 2 if you wanted to. I'm just going to go ahead and divide or simplify that left fraction. So 14x divided by 2 would be 7x. 4 divided by 2 is 2. So I have 7x plus 2 equals 8x. Subtract 7x from both sides to get those x's together. 2 is equal to 1x, or just x. So the value of x I got was 2. Now let's substitute that back in. 3 times 2 is 6, plus 2 makes that top segment 8. 8 times 2 makes my midsegment 16. 11 times 2 is 22, plus 2 makes that bottom segment 24. So do we know what we're talking about? Do we know our algebra? 8 plus 24 is 32. 32 divided by 2 is 16. So we can verify that we are correct. So chapter 8 was all about quadrilaterals, specific kinds of quadrilaterals, parallelograms, and other special properties. So if you have any questions, make sure to reach out and let me know. You are now good to wrap up the homework for this chapter. So lesson 7.5 homework.